Hello friends, welcome to ML with AP. This is the video 3 of the series of videos where we are discussing descriptive statistics. The topic for today is median. Let's learn. Just as a quick recap, descriptive statistics deal with two important topics, the central tendency and dispersion. Central tendency deals with where the location of data is. If we have to give or quantify one number for a series of data, to appropriately locate or tell that where the data is centrally located, that number is called central tendency. Dispersion, on the other hand, deals with the variability associated with data, how diverse the data is, how spread out, how dispersed the data is, right? That is dealt with dispersion. Now the markers for central tendency are mean, median and mode. This is how we typically quantify central tendency. When it comes to quantifying dispersion, we use something called variance, standard deviation, range, skewness, kurtosis, and various other measures, right? Today, we are going to discuss median. So what is median? Median is the middle number of the series when ordered. So if you have a bunch of numbers, what you need to do to find a median is sort them, put them in order, descending or ascending order, put them, and then find the middle number. That middle number is the median. Okay. Now, how to calculate the median? It's very simple. We'll run with the same example what we have been running in the previous two videos as well, right? So we have this data set of students and their placement in lakhs per annum. So there are 15 students and this is how their placement figures are. So we have like a student 10 got lucky, he got a US placement and his 100k salary US dollars, and then converted into Indian rupees, it is 80 lakhs rupees. So similarly, like first student got 3 lakh per annum package, second student got 4 lakh, and subsequently. We are going to rearrange this data into a slightly different form. What? In the median, case of median, we have to sort this out, right? Sort this out. I have sorted this in ascending order. You can sort ascending or descending, doesn't matter actually. Okay, when I sorted this, then if you see the number, the placement packages, this comes in the sorted order. The 80 goes to the last, 3 is the minimum that goes at the top. Okay, now what would be the median of this? The median is the middle number. So there are total how many numbers? 15. What will be the middle of 15th? 8th. Why? There are 7 numbers before that and 7 numbers after that, right? That's how median is calculated. So median is literally in the middle. That's what it means. So it's the 8th position when sorted. The 8th position is 6 lakhs per annum. So my median for this series of data is 6. Why it is 6? This is the middle number. There are 7 numbers above that. There are 7 numbers below that. Okay. Friends, I hope this is clear that what is median. Okay. Now let me ask you a question. What if we have two middle numbers? Let's say in this particular example, we have a 16th student also who got something. If there are 16 data points, then your 8th and 9th row or the number, the 8th and 9th position will become the middle number, right? So you will have two middle numbers in that case. How you are going to get the median out of it? Simple. What you need to do is, if there are two middle numbers, you take the mean out of it. Okay? And then that will be called your median. Okay, got it? Simple. Now let me ask one more thing. In the previous video we have discussed about mean. So the mean, when we calculated, it was coming as 10.33, right? The median is coming as 6. Okay, and this is the data. Suppose if you have to take an admission into a college which publishes such data, okay, that hey, look, these are the previous year's placement figures for my college, please take it, it's so good, please take admission over there. And if you have to take your admission for yourself or for your brother or sister, what would you do? Do you think that the institute or the college was justifying in saying that hey, my average salary is 10.33, or they should have represented that hey, my median is 6 lakhs per annum, not 10.33 but 6 lakhs per annum? Which do you think is accurately represents this data, or which accurately represents the central tendency of this data? where the data is mostly located. Okay, what do you think? Which one is that? If you ask me, number 10, this student got lucky, and because of this 80 number being present over here, my mean has gone very high to 10 lakhs. But if you remove this particular lucky student, right, the average of this, the rest of the 14 students is nowhere close to 10, right? So in another words, this 10 is not accurately representing the package, salary package, the average salary package for this college. Okay, what is being accurately represented at 6 lakhs per annum. So on an average, a median of 50th percentile of these students is receiving median salary. That's why sometimes, friends, in newspaper also you would be seeing that this college, the average salary package is this crore or that many lakhs, right? Be careful about that, because there would be outliers. There only would be bunch of students, few students, 4-5 students who would have gotten very high salary, and that would have pulled the mean very, very high up. Okay, so whenever in such situation, you should always ask the question, hey, mean is fine, but tell me the median. What is the median salary of your college, right? What is the median placement package of your college? That would more accurately represent the true central tendency or the true location of the data. Okay, now let's take another example. Let's take the South Mumbai house prices. Let's say you are doing a survey of house prices in South Mumbai. Okay, and you are walking on the neighborhood, and let's say you are asking the questions to the people, and in the same lane you found the house of Mukesh Ambani also, right? If you have to calculate a mean of that particular lane, what do you think what would be? Because suddenly the house, if you include the house of Mr. Mukesh Ambani, the mean would go very, very high, because his house is probably multi-billion dollars, right? If you, so that is called an outlier, right? That doesn't represent the true nature of the data over there. Okay, that will pull the mean very, very high up for rest of the houses, and you will not be able to accurately get the right picture that, hey, what is the average house prices on that lane, right? What you should do is you should calculate the median. You should get all the house prices, sort them in order, take the 50th percentile. That would accurately represent you the average or the median house price on that particular lane, right? So just to end this median exercise, the median is the most robust of central tendency. Why it is the most robust? Because it is less impacted by the outlier. Now, to calculate the median, we are just getting the 50th percentile, right? If you see over here, we are just getting the 50th percentile. Whether it is 8 or 80 over here, it doesn't matter. So that's why I'm saying that the median is not impacted by extreme values or outliers, in other words. That's why it is a more robust estimate of central tendency. Okay, and you should use that. Okay, let's move on to mode now. Mode is the third marker of the central tendency, and mode is pretty simple actually. What is mode? The number from the series with highest frequency. So whichever number is occurring most frequently is the mode. Okay, so again, our running example, placement package. This is our placement package of the students over here. When I tried to put a frequency table around this, by frequency table I mean these salary, how many distinct salaries are there and how many students got those salaries. So 3 lakh salary was received by 3 students, 4 lakh salary was received by 3 students, 5 was received by only 1 student. Similarly, 80 was received by only 1 student. So I have distributed it into a frequency table. I have written it into a frequency table. To calculate the mode, all we need to do is we have to see that which is the most frequent. Mode is called most frequent. Which is the most frequent salary over here by looking at this figure? So we can say that there are 3 salaries which are appearing 3 times. So 3 lakhs per annum, 4 lakhs per annum, and 6 lakhs per annum. All three are appearing 3 times, right? So salary 3 lakh, 5 lakh, and 6 lakhs are mode, since all three have 3 occurrences associated with it. Now mode can be, this is an example of multimodal data set, right? Where we have more than one mode. You can have n number of modes also. You can have one mode also, unimodal. You can have two modes also, that is called bimodal. If suppose two modes are two most frequent numbers are coming, that is bimodal. Okay, but mode, friends, remember, it's the most frequent occurring observation from the data set. That's all it is. Let's say if this number 6 lakh salary would have been four times, then only 6 would be the mode, because that is the most frequently occurring. It just so happened that we have 3 occurrences of 3, 4, and 5, 3 salary ranges, right? That's why we are falling into a situation of multimodal. Now let me ask you this question. Can we have no mode in the data series? Is it possible that there is no mode? The answer is yes, it is possible. Just imagine a situation where there is no, everybody got a different number of figure over here, right? So nobody got same placement package, okay? So there is 3 lakh, 4 lakh, 5 lakh, 1 lakh, 2 lakh, but it is not repeating. If that would have been the data set, then everything, the number of students would have been 1, 1, 1, 1, 1, 1, 1, 1, right? So there would be no, if you draw a frequency chart, there would not have been any jump, any bump over there, right? And that means there were no mode in the data. It's a flat distribution. It's a flat line, right? If we have to draw on the frequency chart, there is no mode. So it is possible that there may not be any mode in the data. There can be one mode, there can be two mode, there can be 3 mode, or more than 3 modes also. Okay. Now mean, median, and mode, which one we should choose? Okay, so the actual answer is that, well, it depends on the context, right? That which one we should choose. But in general, median always serves you right. Okay, that's why when we talk about, if you see the real estate houses or the websites, right, they always talk about median house prices. When we talk about the salaries in the companies, they always represent that the median salary is this. They cannot represent mean salary, because the CEO and the chief executives would be getting much more, and that will pull all the salary up. That's why they represent median salary. Similarly, the median age also. Whenever we are, for our demography, if we have to account for that, hey, what is the age of this? If you have to find that, what is the average age or most common age, or we have to say that some sort of marker or some sort of characteristic for a particular age group or or demography, we call that, okay, the median age is higher. So if you have to compare to, let's say, the population or the median age of India versus Japan, the people in Japan live much longer. So they will say that the median age in Japan is much higher, right, than median age in India. That would be a right comparison. Okay. Now on the figure, if you see of this, then if the distribution is perfectly symmetrical, and by distribution I mean that if you draw frequency on the y-axis, okay, and my data points on the x-axis, in that case, if the frequency is the graph which comes out is very symmetrical, then mean, median, mode will all exist at the same point. Okay. If the data is negatively skewed, and by that I mean that there are more data which is lying on the left of the graph, right, then my mean will be the extreme right, the mean will be the lowest, median will be after that, and mode will be the mode anyway will always be the top modes, because by definition it's the most frequent occurring element, right? So it has to be the topmost point. Sorry. And if the data is right side skewed, then mean will be higher. This is the scenario of South Mumbai housing, or this is the scenario where we are taking our salary packages, right? Because there one element which was towards the right, which was towards the extreme right, and that's why the mean is being pulled towards the right over here, if you see. And the median is more robust because it is still maintaining somewhere on the left side, right, representing the true nature of the data, and mode will always be the highest. Okay, that being said, I will close this now. I will see you all in the next video. Thank you.